this video, we'll interpret quantitative data using stem and leaf and dot plots, qualitative data with pie charts and Pareto charts, and paired data sets with scatter plots and time series charts. In this example, we're going to start off considering the 40 data points showing the amount spent by couples eating lunch at a particular restaurant. And we want to look at the kind of distribution that the sample is from. So one of the things that we can do is do a stem and leaf plot. Now the stem is the leftmost digit, and in this case that will be the tens digit. And the leaf is the rightmost digit, and in this case it would be the ones, or the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 digit, because the smallest number we have is 9 and the largest is 61. So to create my stem and leaf plot, I know the lowest data point I have is in the single digits, a 9, so I'm going to put a 0 here. Then I have one number that it's 19 in the tens. Then I've got lots of numbers in the 20s, in the 30s, 40s, 50s, and there's a single number here there in the 60s. That's the highest. So the stem in this case is the tens column, and the leaf is the single digits. So I have one single digit of 9, and then if I look for numbers in the teens here, I've got 19. And now there's going to be a lot more numbers in the 20s. So 26, notice how I'm lining up the numbers very carefully under one another. So 26, I'm just putting the 6 part, and 25. So I want to line these up very, very carefully. The next number in the 20s is 24. So I'm going to line that up very carefully here. And then I have 28. Okay, and I'm going to have quite a few here. 21, 26, 23, 25, 26. And then I want to do the same thing for the 30s. So the first one I come across is 39. I'm going to line all the numbers up. Second one, 37. So I want to make sure I line the 7 up under the second digit there, which is 7. Continue to do that. Always include a key when you do a stem and leaf plot. And I'll note here that 9 is actually equal to 19, because in the leftmost column they are tens. When we're done with our stem and leaf plot, we can see that we have roughly normally distributed data. And if you're having trouble seeing the normal distribution, remember that it's not perfect. It doesn't have to be exactly perfect. Now, if we roll this over and put it on its side, we can see a roughly normal distribution. It goes up and then it comes back down. So it goes to a peak about in the middle. So you can create a dot plot to graph quantitative data like this. And in a dot plot, every data entry is plotted. So in this case, the first data entry is a 9. I want to put that right here. And then all future data entries I want to line up on this horizontal. The next highest data entry was a 19. So I want to get it about on the same place. Put it accurately, about 19. Then I have 21. And then the next highest data point was a 23. There's actually 2 23s, and I want to continue to build my dot plot in this fashion. Notice that the dot plot is a little more detailed. We've got dots at approximately the positions along the digits between the tens values, and some students get themselves confused when they look at the dot plot. There's 2 confusions that I've seen in students. The first one is they confuse a stem and leaf plot with a dot plot. So on a test, I ask for a stem and leaf, I get a dot plot, or I ask for a dot plot and I get a stem and leaf. So be sure you know the difference. Now, the second confusion is I see students getting confused and saying, well, this is not normally distributed. But normally distributed starts low here And it doesn't have to be perfect, remember, and it builds up approximately to a high, and then it goes back down. So even though the peak is pretty low in the dot plot, it's still normally distributed. The peak is in the middle. Next, we're going to learn how to create a pie chart. That's a circle divided into sectors that look like pieces of pie. Each one represents a category. So how thick the pie is represents the category. The area of each sector is proportional to the frequency of each category. And we're going to use the example of weighted grades that we have here, where your overall grade in the course is determined by homework 10%, quizzes 10%, chapters, tests 50%, midterm 10%, and final 20%. And they all add up to 100%. We use pie charts to show parts of a whole. In order to create the pie chart, I have to write my relative frequencies as decimal numbers. 10%, of course, is going to translate to be 0.10. And again, I've got 10%. 50% is 0.50. And now what I do is I take that decimal number and I multiply it, so 0.10, multiplied by the 360 degrees that I find in the circle, and that is going to give me 36 degrees. So this is 36 degrees here, and of course this is the same, so this is 36 degrees here. If I wanted to keep a running total, I'd draw the second angle at 72. 50% of 360 is 180 degrees. And if I want to keep a running total, that's going to be 252 degrees. And I can continue in this fashion and fill out my chart. In order to create my first slice of pie, I've got to start with a circle. And notice I have a solid line here drawn as the starting position at the 0 degree mark. Homework comes out at an angle of 36 degrees, so I'm going to need a protractor here. Start from the middle, and I want to go out to about 36 degrees here and make sure, of course, that meets up in the middle, because that's how we slice pie, isn't it? And then quizzes, well, they're 72 degrees. I've got to add 36 degrees again to the 36 degree line for the homework. And in that case, then, what I'm going to need to do is get another line tool, and I want to start here in the middle, and I want to go to about 72 degrees. Now, the third one is chapter tests, and that was a full 180 degrees, so about half. I want to start here and go to about 252 degrees, and that is about half right there, and continue in this fashion. Well, of course, you have to remove the protractor, and when you remove the protractor, you start to fill in different colors for the different slices of pie. That's next. So we can see that this is homework, 10%. This is quizzes, 10%. And fully half is the chapter tests. And this part here, that's your midterm. I'll write that down here because I'm really running short of room here. And finally, the next largest slice is the final. Now, there's certainly ways to make this pie chart more beautiful. One thing you can do is to color code it. So our final product might look something like this. And a lot of people think that it's easier for us to understand these pictures than it is to understand the table of values there on the left-hand side. I will tell you that pie charts are a little bit controversial. Some people think they're a really bad way to show data. But in the case of the weighted grades here, I think they're quite a good description. Remember to only use them when you're wanting to show parts of a whole and you have all 100% available. There's another way to graph qualitative data, and that's to use what's called a Pareto chart. That's just a bar graph, a vertical bar graph, where the height of each bar represents the frequency, but you must order them from the highest to the lowest. So the first thing you see is the most important, the next thing is the next most, etc., etc. A Pareto chart. Next, we're going to talk about paired data sets. The height of a child isn't stable. Of course, it increases over time. And since the pattern of growth varies from child to child, one way to think about this, the general growth pattern, is by using an average of multiple children's heights and looking at the data set. So we're going to do a scatter plot of height versus age, and we expect that to be a straight line. Now, this is data from the Library of Statistics, or publicly available data from Carnegie Mellon University there. So we have here a set of data that compares the age in months with height. So I've chosen to put age on the horizontal axis, age in months, and height in centimeters on the vertical axis. The first data point, when the child is 18 months, this child is about, or all the averages actually of all the children at 18 months was about 76.1, so I'm going to make an estimate of where that is. At 19 months, that's about here, that's about 77, and I want to continue to do this and plot. At 20 months, I have 78.1, so that's about here. At 22 months, it's 78.2. I continue to do that to get a plot of my data. In this particular plot, I can see it's roughly linear. It's not perfectly linear, but if I draw a line approximately through it, it's approximately linear. So I can see the relationship there between the age in months and the height with the scatter plot. The last thing we're going to consider in this video is time series data. How do we do descriptive statistics of that? So time series data is when we're looking at data over a period of time. And this data I got from the World Bank, and it shows the GDP per capita of Australia every 5 years from 1965 through 2015. GDP is the gross domestic product divided by the mid-year population of a country, calculated in local currency units, always measured relative to the US dollar. So in order to plot this data, I want to find the year, 1965, the first data point, and that's about 26, let's say 27,000, so 65 is about here, that's about up here, so I'll put my first dot there. In 1970, which corresponds to this mark, we've gone up to about 32,000, so it hasn't gone up a whole lot. And then in 1975, that's about here, it's gone up to about 30, I'm going to say close to 34,000. In 1980, it's at 36. Now we continue to do this process, and what we want to do is connect all the dots with a line. So once we've completed our time series chart and connected all our dots, we can see the general trend is for Australian gross domestic product per person, per capita, to go up pretty steadily every year. And we probably would expect that trend to continue based on what we see here. So to summarize, we did stem and leaf and dot plots, and that was descriptive statistics for quantitative data sets. Then we looked at pie charts and Pareto charts, descriptive statistics for qualitative data sets. And finally, we looked at scatter plots and time series data, and that's descriptive statistics for paired data sets. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.